There are a lot of different methods to simplifying radicals that you may have learned throughout the years, but really what our goal is here is to break it down into its primes. Here's how I like to do it. I like to do it with cupcake division or upside down division, however you want to call it. I'm going to start with my primes. 300, I'm going to use 2 because 2 is a prime number until I cannot use 2 anymore. So 2 goes into 300 150 times. 2 goes into it 75 times. 75 is not even, so I have to go to my next prime. Well, 3 is my next prime, and I know 75 is divisible by 3. It goes in 25 times. 25, or 3 does not go into 25, but 5 does. 5 times. And 5 goes into it 1 time. And that's what I mean by birthday cake. Is you're going to stop when you're at 1 at the top. So now another way to write the square root of 300 is 2 times 2 times 3 times 5 times 5. So what I'm going to do now is I'm going to group them into pairs, and the reason why I'm choosing pairs is the square root is really the second root. If I had a problem that had the third root, I'd put them in groups of 3. So I'm going to circle, I have a pair of 2's and a pair of 5's. And the pair of 2's will come out, and so will the pair of 5's. So I have 2 times 5, and the leftover is 3. Therefore, when I simplify this, my final answer is 10 rad 3. Let's try the next one. 162. I know 162 is even, and it goes in 81 times. Now, what you should start looking for to help you out is 81 is a prime number. Or not a prime number, a perfect square. The square root of 81 is 9. So I can start right now and take the 9 out because it's a perfect square. And left over I have a 2. If you're not comfortable doing that, then you can take out a 3. 81 divided by 3 is 27. Divided by 3 is 9. Divided by 3 is 3. Divided by 3 is 1. And I have a pair of 3's and a pair of 3's, and 3 times 3 is 9. What else do I have in there? I have 1, 2, 3, 4, 5 x's, and 1, 2, 3, 4 y's. I'm going to circle groups of pairs of groups of 2. There's 1, there's 1, there's 1, and there's 1. Everything that I circle goes to the outside. I already have a 9. I have 2 groups of x's and 2 groups of y's. Left over on the inside, I have a 2 and an x. And there's my final answer. So let's move on to that. Now that we're going to simplify everything, our next goal is we're going to multiply. When you multiply, things do not have to be the same. You can multiply anything that's in the inside. So here's what it's going to look like. If I multiply these two things together, here's what I'm doing. 12 times 3. I have an x to the 4th, a y, an x squared, a y to the 3rd. Well, 12 times 3 is 36. So I have the square root. This is 36. Going back to the last section that I have, if I have 4 x's there and 2 x's there, I have a total of 6 x's. If I have 1 y there and 3 y's there, I have a total of 4 y's. Hopefully we recognize that 36 is a perfect square. Perfect squares, they come to the outside. So I'm going to write that I have the 6. So I have 1, 2, 3, 4, 5, 6 x's, 1, 2, 3, 4 y's. Let's go ahead and circle our pairs. There's a pair, there's a pair, there's a pair and a pair. So what I have is 6, 3 groups of x's, and 2 groups of y's for the final answer. Last problem here, when I multiply multiple things, I'm going to multiply the outside numbers times the outside numbers. So I have 2 times -5, the inside numbers times the inside numbers. So when I simplify this just a bit more, I get -10 square root of 18. So from there, I need to simplify. I'm going to break down 18. 2 is 9. Hopefully you recognize the perfect square and you can take out the 3. If not, we can break it down. 3 goes into it 3 times. 3 goes into it 1 time. So what I'm looking at is negative 10 rad 2 times 3 times 3. Here's a group of 3's. They're going to come out. So that's going to give me negative 10 times this group of 3's that comes out, and the 2 is left over. So my final answer here is negative 30 radical 2.